Have you ever thought that we could actually live forever? No, I haven't gone crazy, and I haven't joined some crazy cult, despite the fact that human life lasts an average of 78 to 82 years. On the atomic level, each of us will indeed exist forever. Even if you should fall into the mouth of an active volcano, or you find yourself crushed by a meteorite, the atoms your body is composed of will remain, at least as long as the universe exists. However, at a distance of almost 100 million miles, about 150 million kilometers from our planet, there is a powerful tool capable of destroying every atom of your body. I'm talking about the sun. What will happen to you on the surface of this star? And how can the sun destroy a human on the atomic level? First, we need to find a way to get to the bright, hot sun. The fastest, though not very economical way to the sun is simply to allow yourself to fall toward it. Right now, the Earth is orbiting the sun at a speed of 67,000 miles per hour, 108 kilometers per hour, and the rotation itself is nothing more than a fall in a sideways direction. However, due to high speed, we do not feel as though we are falling. In turn, if you were to take a spaceship to the sun, you would likewise be rotating around the Earth. Therefore, to reach the surface of the star, you need to stop the rotation of the spacecraft. First of all, it will be necessary to overcome the Earth's gravity. To do this, you'll need to travel away from our home planet by at least 1 million miles, 1.6 million kilometers, which is almost 4 times greater than the distance between the Moon and the Earth. Some modern spacecrafts, such as the Atlas IIAS or Falcon 9, will help you cover this distance. And special rocket engines, such as the RS-68 or Merlin 1D, are capable of decelerating from 67,000 miles per hour, 108 kilometers per hour, to zero. However, the stillness will not last long, because then you will immediately begin to accelerate sharply in the direction of the sun. By the time you reach the sun's surface, your speed will be about 384 miles per second, 618 kilometers per second, faster than anyone has ever traveled in space. It will take you until the 65th day of your fall to the sun in order to reach this speed. The first 64 days of flight will take place without any notable incidents, provided that your space transport is equipped with a special screen that protects you from the heat and radiation. The best option would probably be a carbon fiber screen like the one used for the Parker Research Solar Probe, which NASA sent to the sun. This shield will be able to maintain the temperature inside the spacecraft just above room temperature, about 84 degrees Fahrenheit and 29 Celsius. Even when the outside temperature reaches 2,500 Fahrenheit, approximately 1,370 degrees centigrade. However, 4 hours into your descent to the sun, the temperature will exceed the capabilities of the shield. After all, the magnetic field heats the cornea of the sun, that is, the external atmosphere, to plus 2 million Fahrenheit. That's plus 1.1 million centigrade. But given the fact that you are in the vacuum of space, the temperature will be no more than plus 10,000 degrees Fahrenheit, 5,540 degrees centigrade. However, this is enough to incinerate the protective coating, the spacecraft, and yourself. After that, your remnants will spend some time in the solar cornea, where they will fry at a temperature of plus 2 million degrees Fahrenheit, plus 1.1 million degrees centigrade. As a result, you will turn into the fourth aggregate state of matter, plasma. After that, the magnetic field of the sun will stretch you into a thin thread like spaghetti, and then bend and twist you around itself into the arc of light. This could provide an excellent spectacle for Earthlings looking through a space telescope aimed at the sun, although it will be difficult to notice you. Nevertheless, in this new state, you have a chance of returning home. As soon as you are pulverized into elementary particles, the magnetic field of the sun will launch you back into space at a speed that allows you to cover the distance of about 100 million miles, almost 150 million kilometers, back to Earth in just a few days. So far, everything that I have described is quite possible. So if NASA wanted to turn you into ionized plasma, this could be relatively easy to do by sending you to the surface of the sun. But let's take a little departure from that and imagine that your transport has an improved version of the protective screen that allows you to get further through the outer layer of the solar atmosphere to the visible surface of the sun. Once this happens, the temperature will drop sharply to 10,000 plus degrees Fahrenheit, 5540 centigrade. If the protective coating is not damaged yet, the first thing you will notice is sound. In the vacuum of space, you could not hear your screams, nor the deafening roar of the sun. If this weren't the case, here on Earth, we would hear something like the sound of a motorcycle engine without the help of special listening devices. However, on the surface of the sun, because of the bursting bubbles of gas, the noise will be 100 times more deafening than the most powerful concert speakers. This is enough to form strong blast waves that can easily tear your lungs and other organs to shreds. Suppose you were equipped with super sound insulation and were able to get further to the center of the gas star, where conditions much more extreme than on the largest planet of the solar system, Jupiter, are waiting for you. The main difference between the Sun and Jupiter is not so much a matter of different chemical composition, but a matter of the difference in the ratio of the number of elements. The Sun is thousands of times more massive than Jupiter, which means the temperature and pressure are so high that they allow thermonuclear reactions to occur. Obviously, it is very dangerous to be close to these ongoing nuclear reactions, and even more so to participate in them. Inside the Sun, the temperature reaches plus 27 million degrees Fahrenheit, about plus 15 million degrees centigrade, and the pressure is 250 million times more than on the Earth's surface. This is very bad for human organs that consist, in particular, of hydrogen. That is, for your entire body. In such a heat, the hydrogen atoms will move so fast that they begin to collide with each other, eventually forming deuterium and tritium hydrogen isotopes. In turn, the isotopes will begin to come together, turning into helium nuclei, so you will become a hydrogen bomb. Believe it or not, there is a lot of energy in such a time bomb because, while the sun produces heat, a person is doing even more work than our star. Sitting on the sofa and turning food into energy, humans produce more heat relative to their mass than the sun. What makes a star so hot is its enormous mass. If you were the size of the sun, the amount of chemical energy produced during digestion would bestow upon you the honor of the hottest star in the galaxy. To understand how much energy a human generates, let's recall the well-known Einstein's formula, which each of us has seen at least once in our life, but not everyone remembers its meaning. According to this formula, if you translate 0.03 ounces, about 1 gram of substance into energy, you get the equivalent of the atomic bomb dropped in 1945 on Nagasaki. Accordingly, 2.2 pounds, about 1 kilogram of a substance will yield 25 billion kilowatt hours. That is, an average person who has a mass of 154 pounds, 70 kilograms, when splitting his atoms, can produce more energy than the U.S. coal industry produces in a year. Just imagine how much energy is stored in the entire population of the planet. True, there is no humane way to harvest all that energy. So, in summary, the sun is the most reliable way to destroy you on the atomic level. There are also some less exciting options: nuclear bombs, particle accelerators, or any other source of powerful radioactive radiation. But using one of these options for such destruction on the atomic level will take much more time, which will make death more prolonged and painful. Nevertheless, in the future, scientists plan to learn how to disassemble the human body into separate atoms, though not with the aim to destroy it. This will be necessary for teleportation, when atom by atom your body will instantly move to another point in space. According to physicists from Imperial College London and the University of Glasgow, this technology will be commonplace by 2080. If you want a separate issue on this topic, let me know in the comments. If you liked my video, please give it a thumbs up, subscribe to the channel, and click on the bell so as not to miss notifications about new releases. Be sure to invite your friends. It is more interesting to discuss such topics together.